Hello, welcome again. We are covering the subject Thermodynamics for Civil Services Mains, IFS and various GATE exams. And in this, we are covering the steady flow process applications. Next application is turbine and compressor. So we know that the turbine and engine produce work, and compressor and pump require work or power input. Okay. So to consider this as an application of steady flow process. So this is your turbine. This is inlet condition, this is outlet condition, and it produces WT amount of work. And turbine is insulated so that no heat can cross the turbine. The energy comes from one and goes out and produces work. No external heat is supplied. So this is at the same level. Input and output are at the same level. Okay. So now from steady flow energy equation, which is H1 plus V1 square by 2 plus Z1G plus dQ by M is equal to H2 plus V2 square by 2 plus Z2G plus dW by M. So this quantity is there. Z1 is equal to Z2. This quantity is not there. Okay. And if we assume that at the inlet and outlet the velocity is same, then V1 will be equal to V2. So then the equation will reduce to H1 here only, because Q, Z1, V1 will cancel out, H1 here and H2 here at work here, or this dW by x by dm can be as Wx by m. So this is work done per unit mass, that is equal to change in enthalpy. H1 is your inlet enthalpy, H2 is your outlet enthalpy. Okay. So now in case of compressor, the work is delivered to compressor, so it will be negative quantity here. So it will be H1 is equal to H2 minus Wx by m. Okay. So Wx by m is equal to H2 minus m. Okay. So just reading this out. So this is for compressor, this is for turbine. Just reading this out. Turbine and engine give positive output, whereas compressor and pump require power input. For turbine which is well insulated, the flow velocities are often small. So these velocities are small at the inlet and outlet and can be approximately same, so we can get to it. And it is well insulated. K term can be left. The steady flow energy equation then becomes H1 is equal to H2 plus dWx by dm. So insulated means no heat is being supplied. Flow velocities are same, so kinetic energy is same at the inlet and outlet, and level is also same, so potential energy is also same. So the steady flow energy equation then becomes H1 is equal to H2 dWx by dm, or Wx by m is equal to H1 minus H2. Okay. So next point is, it is seen that, so this is about turbine. Now about compressor or pump, it is seen that the work is done by the fluid at the expense of its enthalpy. The work is done in case of turbine by at the expense of enthalpy. Similarly, for an adiabatic pump or compressor, work is done upon the fluid and W is negative. So the steady flow energy equation is H1 is equal to H2 minus Wx by m. So Wx by m is equal to H2 minus H1. The enthalpy of the fluid increases by the amount of work input. Okay. So this is turbine and compressor application of steady flow process.